Alrighty, let's go ahead and look at this one here. So we've got buying or leasing. If we buy a car, something happens, but if we lease a car, something different happens. So this is where we need to make our little chart here, because we have buying or leasing, and then we have it more than 5 years would be 60%, and leasing the car is more than 5 years would be 10%. And the probability that he leases the car and keeps it, and means multiply this times this, is equal to 2%. So 2% is 0.02, and leasing times 10% is equal to 0.02. Write it out so you know what it is that you're dividing by what, because it matters who's on top and who's on bottom. It makes all the difference in the world. So we've got to make sure we know what we're dividing. So we divide that, we end up getting 80%? So we get 80%. Now, you can always just check it and say, okay, 0.8 times 0.1 is that, wait, what's wrong? Oh, I'm sorry. My bad. That was 20%. 0.02 divided by 0.1 is 0.2, which is 20%. My bad. So 20% times 10% is that. And then this is 80%. I think that's what we were looking for. Probability that he buys the car, yeah. But make a little chart and then fill it all out. All right, so we have Chuck E. Cheese or the park, and then different things about what's happening. So we have Chuck E. Cheese and park, and then we have show up and not, and show up and not. So 25% sure at the park. If so, oh, so this is 75%. If so, at the park, there's a 60% chance of showing up. And if we go to Chuck E. Cheese, everyone's going to show up. 100%. What is the probability that our guest will not show up? We've got this situation and this situation. Well, this times this is 0, so 0 plus what? And then a quarter, 25% of 40% is 10%. So we just have 10%. All right, let's see what else we have. So we have Tyreek. He's playing darts on the dartboard at right. Throws 2 darts. So we have 2 events that are happening. And we want to know the probability that it lands in the shaded and that it lands in the shaded again. And means multiply 1, 2, 3, 4 out of 10 times 4 out of 10. Because this is the probability of shaded and this is the probability of shaded, and we want shaded and shaded. So we do our little multiplication. We get 4 out of 25 when we're done reducing it, which is 16%, and I really could care less which one you wrote, and your teachers will either. All right, let's look at the last 3 on this page. Ooh, bakery, I'm hungry. That sounds good. So we have frosted and chocolate and vanilla and unfrosted and craziness. So 2 items from the display case. What is the probability that are both vanilla unfrosted? That. 3 out of a lot. And is it out of? 3 out of 42. Now, so think about it. That's your first one. You grab it, you have it in your hand, maybe take a bite. You go to grab another one. You do not have 3 in the case anymore. You only have 2. And you only have 41 actual items in the case now as well. So we do a little bit of multiplication and some division and some fun, and we have that. Now, if you don't know how I got that, the 2 reduces with this one, which becomes 21. 3 reduces with 21, which becomes 1 and 7. And 1 times 1 is 1, and 7 times 41 is 287. All right, so what is this one? This one's saying she actually selects a frosted cupcake. So it is frosted, which means I don't care about those guys and I don't care about those guys. So I only care about my 15 plus my 18, which is my 33. And then the probability that it's chocolate is 18, which actually we can reduce because 3 goes into 18 6 times and 3 goes into 33 11 times. So 6 over 11 would be our answer. Our last one here. reaches into the section of the case containing vanilla cupcakes. So she is only talking about vanilla now, which is vanilla and vanilla. So that is 18. We know it's going to be vanilla, and we want to know the probability that she selects 2 unfrosted. So that's, again, I have 3 of them to choose from, and then once one is chosen, I only have 2 of them to choose from, so I can reduce. This will become 1 and 6. I can reduce. This would be 1 times 1 is 1, and 3 times 17 is 51 for the answer.